For this next example, we're asked to integrate from -1 to 1 the natural log of the absolute value of x. And on the surface, this looks like this shouldn't be a problem. Let me show you what the graph looks like, though. Let's see if I can pull this up for you. So here's -1 and here's +1. So you can see that first, the graph is symmetric. This is an even function. But you can see as we approach 0 from either side, that graph is going down to -infinity. So we are going to have to use some limits here. This is a type 2 improper integral. But what I'm going to do is I'm just going to look at half of it. Because this is an even function, because the two sides are symmetric, if one side of it converges, so does the other side. So I'm going to actually look at the right-hand side of it, okay? So let me go back over here to this. So instead of looking at the integral from -1 to 1, what I'm going to do is look at twice. Oops. I'm going to look at twice the integral from 0 to 1. And actually, because the x values are all going to be greater than or equal to 0 here on this interval, I can drop my absolute value bars. So let's see if we can do that. There we go. The magic of this. Okay. This is just simplifying things for me, okay? Just making things a little bit simpler for us. Now, again, at 0, that function is going down to -infinity, so we do need to use our limits. This one I'm going to be able to directly integrate, though. So I've got twice, oops, there we go, the limit as a approaches 0 from the right, the integral from a to 1 of the natural log of x dx. In the integral table, number 116 on that integral table, you'll see the formula to integrate this. And let me write this out. You end up with x times the natural log of x minus x. We're going to integrate that from we're going to evaluate that, not integrate it, evaluate that from a to 1. So I have twice that limit. So starting with the 1, I've got 1 times the natural log of 1. The natural log of 1 is 0, so that part's just a 0, then minus 1. Then we have minus a times the natural log of a minus a. Now, as a goes to 0, this last term will go to 0. Okay, so the limit as a goes to 0 of just a is 0. So that part's done. But we have this bit here in the middle of a times the natural log of a. A couple problems ago, if you hear shuffling, it's just me looking back. It was a couple examples ago. We had looked at the limit of a squared times the natural log of a. And I showed using L'Hopital's rule how that goes to 0. It's very similar for this one. A times the natural log of a is also going to go to 0 with L'Hopital's rule. And I'm not going to take the time here to work it out, but it is in my written notes. You can see that. So as a goes to 0, both the terms in the parentheses go to 0, so I'm just left with a -1. So this integral is going to be, it's going to converge to 2 times -1 or -2. So it converges, and it converges actually to -2. Here we have the actual value.